there, amazing people, students, and all the lovers of chemistry out there. I am super excited to be here with you on today's episode of Question for the Day. And on today's episode of Question for the Day, we're going to be looking at how to calculate the empirical formula of a compound. So let's get into details. The question says a compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen by mass. We have been asked to determine the empirical formula of the compound. Now, on the screen right now, we have the steps for determining the empirical formula of a compound outlined. So let's take each step one at a time and derive the empirical formula of the compound. So step number one says assume 100 grams of the compound. What does this mean? It means that all these percentages that we have, 40%, 6.7%, and 53.3%, simply change this percentage into grams so that when you add everything together, it will result to 100 grams. So step number one, let's do that very quickly. We have carbon. Carbon will now be 40 grams since it was 40% initially. And then we have hydrogen. Hydrogen will now be 6.7 grams. And then we have oxygen. Oxygen will now be 53.3 grams. So now that we've done step one, the next step says convert masses to moles. Now there is a formula for converting mass into moles, and that formula says number of moles N is equal to the mass of a substance divided by its molar mass. Okay, so now let's start with carbon. For carbon now, N will now be equal to the mass of carbon is 40 grams. So we have 40 divided by the molar mass. Now what is the molar mass of carbon? The molar mass of carbon is 12. Okay, if you check the periodic table, you'll find these are constants. So the molar mass of carbon is 12. So when we say 40 divided by 12, that gives us 3.333. So let's write that out. We have 3.333 moles for carbon. Now let's do the same for hydrogen. Hydrogen will now be, the number of moles of hydrogen will now be 6.7, which is the mass, divided by the molar mass, which is 1. So we have 6.7 moles. I'm sure you're seeing how each step is being carried out. And then for oxygen, number of moles will be equal to the mass, which is 53.3, divided by the molar mass, which is 16. So when we say 53.3 divided by 16, that gives us 3.333 moles. So now that we have the number of moles ready, and then we have assumed 100 grams of the compound, step number 3 says divide all by the smallest number of moles, which is 3.33. So let's do that very quickly. For carbon, we have 3.33 moles. For hydrogen, we have 6.7 moles. And then for oxygen, we have 3.33 moles as well. So now the smallest number of moles is 3.33. So we're going to divide by 3.33. The same thing we're going to do over here, divided by 3.33, since the smallest number is 3.33. So when we do that, for the first instance, we have 1. For the second instance, what we have is 6.7 divided by 3.33. That gives us 2. And then for the third one, we have 1. So now that we have done that, this last step says write the empirical formula. How do we do that? We simply assign all these numbers to their individual elements. Carbon now has the number 1, and since it has the number 1, let's identify it first before we write out the final answer. Hydrogen has the number 2, and then oxygen has the number 1. So now when we're writing out the empirical formula, if its number is 1, there is no need to identify it or write it out, okay, because the letter already shows that it is 1 that is present there. So we have the final empirical formula to be CH2 and O. This is the empirical formula of the compound. I'm sure you saw how every step was carried out. I'd like you to please subscribe to this channel if you found this video educative enough. Like this video and turn on the notification bell icon so when more bangers like this are out, you'd be the first to be notified. Up until I come your way next time, my name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. I'll see you in the next video.